I welcome all the students. Today we are going to learn the topic that is filling area primitive. Okay, under the filling area primitives, I think we already covered the points scanline, polygon filling, inside outside test in the last session. So today we are going to learn the point boundary fill. Okay, the point and the topic we are discussing today is boundary fill. Okay, and then the last point we are having is flood fill algorithm. Okay, so today's session we are going to concentrate on the point which is known as boundary fill algorithm. Okay, so let us start the discussion of boundary fill algorithm. Now, first we are going to learn theoretically what is mean by boundary fill algorithm. Okay, so let us understand what is boundary fill algorithm. Okay, now this approach of area filling is, you can start at a point inside a region and bend the interior outward towards the boundary. Okay, so in the boundary fill algorithm, we have to start filling the area or filling the polygon at a point which is inside the region. Okay, so I will start from the any point which is inside the region and then just goes on painting the interior outward towards the boundary. Means I just goes on continue this until I reaches to the boundary area. Okay, now if the boundary is specified in a single color, okay, so now here I am considering the boundary color is different, boundary specified in a single color, and the fill algorithm proceeds outward pixel by pixel until the boundary color is encountered. Okay, so my algorithm is going to fill the color pixel by pixel until I reaches to the boundary color. Okay, so we are considering here the background color is different, boundary color is different, boundary color of the polygon is different, and the fill color of the polygon is also different. Okay, so we are considering, that's why the boundary is separate. Okay, so that's why the all these algorithms called as boundary fill algorithm. Okay, so that is what I have written here, that we have this method is called boundary fill algorithm. Okay, now these methods of boundary fill algorithm are useful in interactive painting packages. All the interactive painting packages where the interior points are easily selected. Okay, so this is what the main use of boundary fill algorithm. They are used in interactive painting packages. All the interactive painting packages uses the boundary fill algorithm. Okay, now let us understand the procedure of the boundary fill algorithm. The boundary fill procedure accepts as input. Okay, so what is the input given to the algorithm? What input we have to give to the algorithm is the coordinates of the interior point x comma y. So what is my first input that I am going to give to this boundary fill algorithm is the interior point or any point which is inside the polygon having the value x comma y. Then we are giving what should be my fill color. I want to fill this with, fill the polygon with which color, so I call it as a fill color, and what is my boundary color. Okay, so boundary color means whatever the with which color I have drawn the polygon. Okay, so polygon lines are drawn with whatever color, I call it as it is my boundary color. So I have to give this three input to the algorithm. The first input is important, which is the interior point, any point which is inside the polygon. Then a fill color. Okay, so I want to fill the polygon whichever color, and then I have to give the boundary color. So these are the input that we are giving. Okay, now starting from x comma y means starting from the interior point, the procedure test neighboring position means I know now the interior position point x comma y. Now I'm going to test the neighboring position, I'm going to test the neighboring point. Okay, to determine whether they are of boundary color, whether the neighbor of this x comma y, whether they are having the boundary color. If not, if they are not having the boundary color, then what we have to do, if not, they are painted with the fill color. So I have to fill those neighbor pixel also with the fill color, and their neighbor pixels are again tested. So I just goes on considering all the neighbor pixels until I reaches to the boundary color, or I reaches to the boundary. Okay, so that's why we are written the last point. This process continues until all pixels up to the boundary color are tested. Okay, so unless and until we get all these pixels of boundary color for the area have been tested. Okay, now to understand this in simple words or with the example, okay, boundary fill algorithm procedure or the idea, what I'm going to do is, okay, I will just draw the my one triangle. Okay, so I'm just drawing the triangle with black color. Okay, so here just look at this diagram. I'm just showing you the example. So this is my polygon. Okay, so my polygon is triangle. Okay, so for this polygon, which is my background color? Obviously my background color is white. Okay, because I have drawn this on the white background. Getting me? This is on the, this polygon is on the white background. Okay, and what is my boundary color? I have drawn this polygon with black color, so my boundary color in this case is black. Okay, so black is my boundary color. Okay, and suppose I want to fill this with now the I change the color now. Now I want to fill this with the brown color or red color. Okay, so what is in my procedure? Okay, I just take any one pixel which is inside. So this is my inside pixel. Okay, what I will going to do is, once I know that pixel, I fill this with the color. Then I will consider its neighbor pixel. Okay, which are the neighbor pixels I am going to consider, and these neighbor pixels are also filled with the color. Again its neighbor pixel is filled. Now till until I reaches to the boundary. Okay, now when I reaches to the boundary, I'll come back again. I will move in another direction. Again I will move in this direction. So in this way I just goes on filling this polygon, and that filling will be aid whenever I reaches to the boundary, it will come back. Okay, and again it will just goes on filling this. Okay, so this is what the fill color is, brown or red, the boundary color is black, and background color is white. Okay, so this is what we have to consider. So this boundary color is different than the fill color and background color. That's why I'm considering the boundary of the polygon. So that's why this is known as boundary fill algorithm. One very important thing that we should note is, this boundary fill algorithm does not work on scan line approach. Okay, so scan lines are not considered in the boundary fill algorithm. Getting me? So I'm not considering the scan line approach. Okay, so let us move to the next point to understand the things in detail. So I'm just moving to the next slide. Now, if you can look at this particular diagram, I have just drawn this diagram just for example. We are just considering this example. Example, color boundaries for a boundary fill procedure. Okay, so just it had shown that suppose this is my, I call it as the polygon, or this is my object. Okay, and I want to fill this with the blue color. So fill color is blue. Okay, but my background color, you can say, I think the obviously the background color is white, but my boundary of this polygon, maybe suppose I am finding it here as yellow color, or any black plus yellow or brown color. So this is my boundary color. Okay, so this is my boundary of my object. Okay, similarly here also you can find that this is the boundary of my object, this is also the boundary of my object. Getting me? Okay, so I must have this boundary is there. Now this may be filled with different color, remaining will be filled because this is the polygon which is having the boundary. So this is my boundary. So inside the boundary I can fill here red color. Okay, for this particular boundary I can fill the blue color, and so on. Okay, so this is the way we are going to fill this polygons or the object. Okay, so let us consider. Okay, so we are, yes, definitely we are considering this diagram, but I want there, before that, everyone should understand this. There are the two methods for proceeding to the neighboring pixel. How we are going to consider our neighboring pixel, how the neighboring pixels are considered from the current pixel position. Okay, so there are the two methods. Okay, whenever I consider the neighbor pixel of my current pixel, I am having two methods. First one is diagram A. Okay, so that is diagram A, which is known as four connected pixel. So this A diagram is shows that it is a four connected pixel. So I'm considering my neighbor as a four connected. Okay, these are the pixel position that are, so I'm having my neighboring pixels as left, right, above, and below. Okay, so let us look at the diagram. Now in this diagram, this is my, remember, this is my current pixel. Okay, this is my current pixel. Getting me? This is center pixel is my current pixel. Now I consider the 4 neighboring pixel of this, how one is left. Okay, so I consider for this is my left side of the pixel. So this is the left pixel, this is the right pixel, neighbor pixel, this is the above or up pixel that we are having, and this is the below or down pixel. Getting me? So what we are going to consider here is, we are going to consider all these 4 pixels. Okay, 4 connected pixels. Now what we are going to do, suppose I have taken this pixel, okay, which is at the left or right side, or this is at right side. I will check whether it is already filled with the color, or whether it is a background color, or it is boundary color. It is already filled with the color, no, it is having the background color. Whether it is boundary color, no, it is not boundary color, so this will be filled with the color. Okay, and after filling this with the color, I considered this will be my current pixel now. So definitely I will consider all the 4 neighboring pixel, and my next pixel will be again this. Again I consider its 4 connected pixel and so on. Okay, so we are having one more approach for this, that is shown in the diagram number B. So in the diagram number B, so in boundary fill I can use the 4 connected neighboring pixel, or I can use 8 connected neighboring pixel. Okay, as shown in the diagram number B. So B shows 8 connected pixels. Now these are the pixel positions which uses the 4 diagonal pixels. So additionally we are considered 4 diagonal pixels in addition to 4 connected pixels. So here I already have having the 4 pixel in left, right. So I'm having the pixel at left, then I'm having at the right, I'm having the top or above or up, and then I'm having the below or downside. So these are the 4 connected, but I am also considering all these 4 diagonal direction pixel. Okay, so I am taking this also as a into account. So this is called as 8 connected pixel. So this is known as 8 connected pixel. So for considering the neighboring pixel, I am having the 2 approach. I may consider the 4 connected, or I may consider the 8 connected pixel. Okay, so let us move to the this. I hope so everyone is very much clear what is 4 connected neighboring pixel and what is 8 connected neighboring pixel. Okay, so let us move to the next point that we are having. So now what we need to consider is, we are need to consider the algorithm. Okay, actually now there is one algorithm, suppose I call it as, generally it is known as seed fill algorithm. Okay, so this seed fill algorithm is comes under the boundary filling algorithm. I think we have learned edge fill algorithm in previous session. That edge fill comes under the scan line approach, okay, or scan line scan converting polygon. We have learned edge fill algorithm. So the seed fill algorithm, okay, is comes under the boundary filling. Okay, so now we are going to learn the algorithm as seed fill algorithm. Now it assumes that this seed fill algorithm assumes that one pixel, at least one pixel, generally we call it as a seed pixel, or at least one pixel, which is a seed pixel, interior to the polygon or the region is known. So what is my requirement of the seed fill algorithm is that I must know at least one pixel which is inside the polygon, and that pixel is called as seed pixel. We are calling this pixel as a seed pixel. Getting me? Now the interior or the boundary defined regions, now after knowing the seed pixel, interior or boundary defined regions are either 4 connected, or I will use that as the 8 connected. Just now we have seen I can use the 4 connected, or I can use the 8 connected. Getting me? Now I want just we will going to look at this. Okay, the simple seed fill algorithm using a stack. Okay, so I think what we are going to use is, if I can implement this with the help of the stack. Okay, everyone knows what is the stack. Stack is a one of the data structure which is having the property as last in first out. Okay, so generally I consider this as a stack which is having only one end is open. Okay, so if I'm going to put my pixel into the stack, okay, then this maybe, suppose I have inserted A here. Okay, so this is my atom A. Okay, this is my atom B. Okay, so A is inserted first, after that I'm inserted B, then I have inserted C. Okay, so what is after inserting A, B, C, I cannot remove B and A until I remove the C. So it is called as the last inserted is C, but which is going to out first, it is the C again. So this is called as last in first out. Okay, so we are going to implement using the stack. Okay, Now whenever I insert anything into the stack, it is called as the push operation. And whenever I'm going to remove from the stack, okay, from here if the atom goes out, okay, remove from the stack, it is called as the pop operation. Okay, so just understand the simple seed field algorithm here. What we have to do initially, what is the step number one? Push the seed pixel onto the stack. So I'm going to insert the seed pixel inside the stack. Why? And now I'm having the while loop while the stack is not empty, until it is not empty. What is my step number one? Pop a pixel from the top of the stack. So I'm going to remove the first pixel. Now set that pixel to the required value. Okay, now set the pixel to required value means what? Required value means in this case I set to the fill color. Okay, I'm going to set this with the polygon filling color. Okay, now after that what I'm going to do, for each four connected pixel which are adjacent to the current pixel, okay, for each of the four connected pixel adjacent to the current pixel, we are going to check if it is boundary pixel, whether out of these four connected, whether the pixel is boundary pixel, okay, or it is already been set to the polygon color. Okay, so these are the two things that we are going to consider in our algorithm. Okay, for each four connected pixel adjacent to the current pixel, we check whether it is boundary pixel or whether it is a already filled with the color. If not, we are going to insert it into the stack, and this procedure is continued. Okay, so we can do this, okay, until I reaches to the boundary value. So this is what the simple algorithm. Okay, now I think you have got the idea of what is the algorithm. Now we will go into the more detail of the algorithm. Okay, so now I am moving to the next slide where we are going to learn this seed fill algorithm in detail. Okay, so just let us move to the next slide. Now here, now you may come to know that we are using this for 4 connected. We are not considering the 8 connected pixel here. So we are considering it is how it is implemented using 4 connected. So this is my simple seed field algorithm for 4 connected boundary defined regions. That's why it is called as the boundary fill. Okay, boundary fill algorithm. Okay, now here, what is my step number one? I'm using the seed x comma y is the seed pixel. So I'm having the seed x comma y seed pixel. Push is the function for placing the pixel onto the stack. Pop is the function for removing the pixel from the stack. Push operation means place the pixel on the stack. Pop means remove the pixel from the stack, is known as pop operation. Okay, so what is initially I'm going to do? Now this pixel x comma y is nothing but it is my current pixel. My current pixel is pixel x comma y, which is equal to seed x comma y, because I'm going to consider my seed pixel. I'm going to consider my seed pixel is my current pixel now in initial state. I just draw the diagram here. Okay, assume this is your triangle. Okay, now this triangle is having which color? Boundary color. It is having the boundary color as brown. I cannot take same. It is, suppose I want to fill this with, suppose assume that I want to fill this with the blue color. Okay, so I will give one pixel as my seed pixel. Assume this is my seed pixel. Getting me? So this is my seed pixel, seed x comma y. Now this is my current pixel. Okay, the same pixel is my current pixel. Okay, now what I'm going to do, I'm going to put this pixel onto the stack. Now this is my current pixel. Initialize the stack, push the pixel x comma y onto the stack. While stack is not empty, I'm going to pop the pixel x comma, means I'm going to remove the same pixel now. Same pixel is I'm going to remove. Then I will check whether the pixel x comma y is not equal to new value. It is not equal to new value means it is fill value. You can consider it is not filled with the color. Then I am going to fill this with the color. So what I am going to do here is I am going to fill this pixel with the blue color. Okay, so the seed pixel is filled with the color. You can find I am filling this with the color. Okay, now after this what I need to do, I need to examine, I need to consider the surrounding pixel or neighboring pixel to see if they should be replaced onto the stack or not. So which are the 4 connected pixel of my seed pixel? So if I just consider this is my one pixel, this is my, I'm just now drawing the neighbor pixel with the higher size to understand. This is my another neighbor pixel, this is my another neighbor pixel. Getting me? So these are my 4 connected pixel. Okay. Now suppose this is x. What is the value of this pixel now? This pixel is having the value x plus 1 and y. Y value as it is. So this is my x plus 1 comma y. Now what about this pixel? Okay, this pixel, if I consider this one pixel, this pixel is having x value minus, so this will be x minus 1 comma y. Okay, if I considered in my program, this is my 0 comma 0, this is my center of the screen, then what is the value of this pixel? This pixel will be, y value is incremented, so it is y plus 1 comma x, x is as it is, and this will be y minus 1 comma x. So these are my 4 neighboring pixel. Okay, so I will take my first pixel, first neighbor pixel. What is my first neighbor pixel? Pixel x plus 1 comma y. So this is my x plus 1 comma y, this one. Okay, I will check whether it is set to the new value or polygon color, no, and whether it is also set to the boundary value, whether it is boundary color, no, boundary color is my brown color, it is not boundary color. So what I'm going to do, I'm going to push this pixel onto the stack. See, when I'm going to pop this pixel, obviously it is filled with the color. Okay, because it is not set to the fill color and not set to boundary color. Okay, so similarly I'm going to consider all these 4 pixels. Okay, so just move to the next slide. The algorithm is continued. I hope so. The algorithm is continued now. Only I have covered only x plus 1 comma y, so the algorithm will be continued for remaining 3 neighboring pixel. Okay, that is there in the next page or next. Yes, we are now considering this is the pixel x comma y plus 1, x minus 1 comma y, and x comma y minus 1. So now I am considering all the 3 neighboring pixels. First pixel is x plus 1 comma y. This is my second pixel. First pixel we have seen in the previous slide. The second pixel is comma y plus 1. This is my third neighbor pixel x minus 1 comma y, and this is going to be my fourth pixel x comma y minus 1. Okay, for all this pixel, what I'm going to check whether it is not set to new value, whether it is not equal to new value, and it is not the boundary value, then and then only you are going to push it or you are going to activate with the fill color. Okay, because when you are going to push it on the stack and when you remove it from the stack, you are going to fill it with the color. Okay, so that is what the procedure we are having to push that pixel. Only push that pixel only when that pixel is not filled with the color and that is not the boundary color. Okay, so this is what, and I'm having the end of the while loop. So this while loop will be continued, okay, unless and until my condition fails. My condition, when my condition fails, if the neighboring pixel is filled with the, this is false. If the neighboring pixel is already filled with the new value or polygon color, then it will be terminated. Or if the pixel is already set with the boundary value, means I reaches to the boundary value. If I have reached the boundary value, definitely we are going to terminate the while loop. Okay, I will come out of this while loop. Okay, now see, this is what our seed fill algorithm, which comes under the boundary filling algorithm. Okay, and which uses, now this algorithm uses the push and pop operation and the stack. Okay, so now I'm having one more option to do my algorithm for seed fill algorithm or the boundary fill algorithm. I'm having one more option, that is I can do this implementation or do this program using recursion. Okay, because if I use recursion, my program will be very easy. Okay, because the recursion, everyone knows that the recursion internally uses the stack data structure. Recursion uses the stack data structure, so internally it will go for this push and pop operation. Okay, push pop operation will be done internally, so it is better that we can also use the recursion. Okay, so that's why I'm having the next slide, so where we are going to learn the algorithm of the seed fill using recursion. Okay, so let us move to the next slide to understand the recursive procedure for boundary fill or seed fill algorithm. So this is what my recursive function. The following procedure illustrate or it is going to show the recursive method. The procedure using recursion, recursive method for filling a 4 connected area. Okay, 4 connected pixel with an color or intensity specified in the fill color. So what is mean by the fill variable? The fill indicate it is my fill color. I want to fill the polygon with yellow color, then my fill color is yellow. Okay, up to a boundary color specified with the parameter boundary. So what is this boundary indicate? Variable boundary indicate that I want to fill the polygon with boundary color. Okay, now suppose I have drawn the triangle with black color, then my boundary is black. Okay, so polygon lines are drawn with whatever color, that will be my boundary color of the polygon, and I want to fill this with the color, suppose yellow, then yellow will be my fill color. Obviously, if I consider this as a slide, this slide is having the background color is white. Okay, so background color of this slide is obviously it is white. Getting me? So that is what we are considering. Let us look at the procedure, recursive procedure that we are having. Okay, I want everyone to concentrate on the algorithm. Now this is my recursive function. The name of recursive function is boundary fill 4. Boundary fill 4. Why this 4 is there? Because I'm using 4 connected areas. That's why it has written 4. Boundary fill is the name of my recursive function. Boundary fill 4 is my recursive function. What value we are passing? I think we have learned in the first slide. We have to pass the seed pixel, or we have to pass the current pixel. Current pixel is x, integer y. X and y is my current pixel. Then I have to pass the fill color. I want to fill the polygon with which color, and I also have to pass the boundary color. What is the boundary of the polygon? The boundary color of the polygon should be passed in this recursive function. Okay, now I am using one variable as current or current color. Okay, I say instead of current I can use it as a current color. Okay, what is my current color? How I will get the current color of the pixel? Okay, I am having one function which is known as get pixel. Get pixel is the function. Okay, what this get pixel function does, it will get, or it will find out the color of the given x and y pixel. So get pixel bracket s comma y will find out what is the current color of this pixel, and it is written this color that is stored in the current. Okay, so this current variable, current integer variable will give me what is my current color of the pixel. Okay, so now what I have to do, if my current pixel, current color of the pixel is not equal to boundary, it is not set to boundary color, and the current pixel is not already filled, it is not equal to fill color. If current pixel is not equal to boundary color and current pixel is not equal to fill color, means current pixel is not boundary and current pixel is not filled with the color. Okay, then what I have to do, obviously I have to fill that with the color. So I'm going to set color fill, and I'm going to put pixel or set pixel x comma y. Getting me? So I'm going to fill this with the color. Okay, after that in my recursive function, what I have to do, I have to check the 4 neighbor pixel. I have to now concentrate on the 4 neighbor pixel. So which are my 4 neighbor pixel? Just now we have seen it may be x plus 1 comma y. Second neighbor pixel is x minus 1 comma y. After that next pixel is x comma y plus 1 and x comma y minus 1. So these are my 4 connected pixel, 4 neighboring pixel. So what I have to do, I have to pass these 4 pixel recursively to the same function, because I am calling the same function inside the function, so it will be recursion. I am again calling the boundary fill, but now my current pixel will be x plus 1 comma y. Getting me? So I think just now we have seen, suppose this is my current pixel, then which is my x plus 1 comma y, x is incremented y as it is, and this pixel is my x plus 1 comma y, which is my x minus 1 comma y. Suppose this is my current pixel. Okay, current pixel is already filled with the color. Getting me? This is my x plus 1 comma y. What is my x minus 1 comma y? So this pixel is my x minus 1 comma y, which is my x comma y plus 1. Y is incremented, so this is my x comma y plus 1 pixel, and another last neighbor pixel which is remaining, x comma y minus 1. Getting me? So I just pass all these 4 neighboring pixel, I'm going to pass all these 4 neighbor pixel recursively to the boundary fill algorithm or the recursive function by passing this. Okay, again what will happen in this case, if suppose I have passed x plus 1 comma y. So now that x plus 1 comma y is passed recursively to here, it will comes here, again it will go for current pixel is now x plus 1 comma y, it will get that pixel value. Now it will check whether what is the color value of this pixel. The color value of this pixel is white. Okay, white means it is set to the background color. Okay, not boundary color, it's set to background color. Background color is white. Okay, now it will check whether the current pixel is not equal to boundary color. No, it is not boundary color, it is white color. Boundary color is my different color. And whether it is set to the fill color. No, it is not set to the fill color. So what I am going to do, I'm going to set that pixel with fill color and I'm going to activate. So what I'm going to do, I'm going to fill this with the, I'm going to fill this particular pixel with the color. Getting me? Again I come to this side, again I will come boundary fill x plus 1. So now this is my current pixel, again I am going to pass its x plus 1 comma y, means this pixel. Now I'm going to pass this pixel recursively. Okay, and in this way the procedure will be continued recursively, it will continue. When it will stop, now suppose this is, okay, I've just changed the color, suppose this is red. Okay, suppose assume this is my triangle and now this is my boundary. Okay, so after filling this, okay, now I will come to the color, I will come to the pixel which is boundary color. It's set to the boundary color. If it is set to the boundary color, what is going to happen, it my condition fails. If current is not equal to boundary color, yes, the color is set to boundary color, so this condition is fails. So I will come out of the recursion, I will come back, and again I will start examining x minus 1 comma y. So I will move in this direction. Initially I am moving in this direction, I will move in this direction. When I reaches to the boundary, in this direction I will come back. Okay, again I will move, what is my next value is x comma y plus 1. So in that case I will just move in this direction. Okay, and at the end I will just move in the this direction and just goes on filling all the pixels with the appropriate color. Okay, so this is what the algorithm, I call it as the boundary fill. It is also known as seed fill algorithm. It is also known as seed fill algorithm, and it is also known as boundary fill algorithm. The boundary fill algorithm, and this is what, whatever we have shown, this is called as a recursive procedure, recursive method for filling the polygon with the given color. Okay, again I say, I think we have come to the conclusion of boundary fill algorithm. We have understood in so many ways what is meant by the boundary fill algorithm, what is meant by the seed fill algorithm, and what input we are giving. We are giving this input as integer x, integer y. So current pixel is given as the input, then I must know what is my fill color, want to fill the polygon with which color, and I must know what is the boundary color of the polygon. If these things are known to me, okay, it is possible for me to fill this polygon with the color. Okay, suppose I consider this is my triangle, my polygon is my triangle. Okay, so my boundary color in this case is, my boundary color is brown. Brown is boundary color, fill color is blue, and background color is white. Okay, so I'm having these values, and accordingly it is possible for me to fill this with the blue color. Okay, so this is what we have learned today, what is meant by the boundary fill algorithm and seed fill algorithm. Okay, so in the next session, okay, instead of moving to the next point, we are going to learn the C program, how this seed fill algorithm or how this boundary fill algorithm can be implemented in the C program, and how I will get the output of it, how I will get that my polygon or my triangle is filled with the color. Okay, so practically we are going to see in the next session how this boundary fill algorithm or how this seed fill algorithm is implemented, how it can be used. Okay, so I hope so all of you have learned, okay, or understood in detail what is boundary fill algorithm or what is seed fill algorithm. Okay, so I say thank you all of you. Okay, thank you all and take care. Thank you.